I am Uma RM, AP of EEE Department in Sri Muthukumaran Institute of Technology. Now we are going to see about basic electrical electronics engineering. The first unit is DC fundamentals. Now we are going to discuss on it electrical quantities. So the electrical quantities describe the behavior of electrical circuits. They help in analysis and design of circuits. First, let us see on what is voltage. Voltage is defined as work done per unit charge. It is given by V equal to W by Q, where V is the voltage or potential difference, W is the work done, and Q is the charge. Next, current. Current is defined as flow of charge per unit time, or it can also defined as the current is the rate of flow of electrons in a conductor. It is measured by number of electrons that flows in a unit time. So I is given by charge by time, that is nothing but Q by T, where I is current and Q is charge of electrons and T is the time. Work. Work is the force applied to the body cause it to move, and if a displacement D is caused in the direction of the force, then work done is given by force into distance, that is W equal to F into D. Now let's see power. Power is the rate of which work is done, rate of doing work. The unit of power is joules per second, which is also called watt. Now the classification of network elements. Network elements are classified into active elements and passive elements. Active element are further classified as current sources and voltage source. Passive elements are nothing but resistor, inductor and capacitor. The network elements are also classified by linear and nonlinear, unilateral and bilateral, time variant and time invariant, lumped and distributed networks. While discussing the network theorem, laws, and electrical electronic circuits, one often comes across the following terms. Let's see one by one. Circuit. A circuit is a conducting part through which an electrical current either flow or is intended to flow is called a circuit. Electric network. The combination of various circuit elements connected in a manner is called electric network. Next, linear circuit. The circuit whose parameters are constant, that is, they do not change with applications of voltage or current, is called linear circuit. Non-linear circuit. The circuit whose parameters change with the application of voltage or current is called non-linear circuit. Then, circuit parameters. The various elements of an electric circuit are called its parameters like resistance, inductance, and capacitance. Next, bilateral circuit. A bilateral circuit is one whose properties or characteristics are the same in either direction, for example, transmission line. Unilateral circuit. A unilateral circuit is one whose properties or the characteristics change with the direction of its operation. Example, diode rectifier. Active network. An active network is one which contains one or more sources of EMF. Passive network. The passive network is one which does not contain any source of EMF. Next, node. Node is a junction in a circuit where two or more elements are connected together. Branch. Branch is a part of network which lies between two junctions called branch. Loop. A loop is closed path in a network formed by a number of connected branches. Next, mesh. Mesh any path which contain no other paths within it called a mesh. Thus, a loop contain meshes, but mesh does not contain a loop. Next, lumped circuit. The circuit in which circuit elements are presented mutually independent or not interconnected. That is, the circuit elements can be separable from the circuit. Next one, we are going to see about electrical circuit elements, which are nothing but resistor, inductors and capacitors. These are the three basic parameters or the circuit components of any electric network. Now let's see about what is resistor. A resistor is a Okay, let's see like this. The resistor is nothing but which opposes the flow of current. The electrical resistant is the opposition of the flow of electrons in a given material. It is also defined electric a resistor is the property of a material due to which it opposes the flow of electric current through it. The property of a material is restricted to the flow of electrons is called a resistance. The resistance is denoted by R and it is represented by R is equal to L by E. It depends upon the length of the resistor and area of cross section. The symbol of electrons are shown in the figure. The unit of resistance is ohm and symbol is ohm, and the conductor depends on following factors. As I said, it depends on length, cross section of area, and also it depends on the nature of the material and also depend on the temperature of the conductor. Next, inductor. If the energy is stored in a magnetic field, the element is inductor. The unit of inductor is Henry, denoted by H. The circuit symbol is shown in the figure. The inductance coil is defined as the ratio of flux linkage to the current flowing through the coil, wherein is number of turns, pi is flux and I is current, and L is given by N pi by I, and the relation of V for the inductance is given by V is equal to L d I by dt, that is with the change in time. Next, the capacitor. Capacitor is the energy stored in the electric field. The element is called capacitor. The unit of capacitor is farad, denoted by F. The circuit symbol is as shown in the figure. So the charge of an capacitor is charge is directly proportional to V, or charge is equal to CV. The relationship with the capacitor and the current is given. I is equal to C dV by dt. Similarly, with the voltage, V is equal to I by C integrated of I into dt. The reference of this basic electronics and engineering, these are the books that has been taken as the reference to have this PPT. Thank you.